Okay, so this is the practice problem looking at how to calculate acceleration. So the file is acceleration number 1. And it reads, a car is traveling at 35 meters per second when it notices a stoplight up ahead. That sounds familiar. A lot of our examples had to do with that car traveling to the stoplight. What is its acceleration if it comes to a stop in 10 seconds? So we're just using this to practice the equation that we use to calculate acceleration. So let's remind ourselves what that is. The average acceleration is our change in velocity, how the velocity is changing as time of the motion goes on. So our change in velocity, delta V, over our time of the motion. So our final velocity minus our initial velocity over the time of the motion that we're interested in. So what is our final velocity? Well, the problem says that it comes to a stop. So the stop becomes part of the motion we care about. Our final velocity, it gets to 0 meters per second. What about our initial velocity? Well, it says it's traveling at 35 meters per second. And it tells us that this change in velocity happens over a time of 10 seconds. So what is our average acceleration? V final is 0. V initial is 35 all over 10. We get an average acceleration of negative 3.5 meters per second. Because that positive and negative is important, let's look at if it makes sense. We said we had a velocity of 35 meters per second. That's positive. That's moving to the right. We're moving to the right and we're going down to 0. We're slowing down. Moving to the right and slowing down means that the acceleration, slowing down in general, means that the acceleration and the velocity are in opposite directions. If I'm moving to the right, my acceleration must be to the left if I'm slowing down, and sure enough, that's what we calculate it to be. So it's consistent. I really encourage you to always examine that direction of acceleration and always be thinking about it as you are identifying it in problem solving so that we work through that misconception of what a negative acceleration means. So it's negative in this case because we're moving to the right and slowing down, and they need to be opposite. Good job.